Hey everyone, welcome to Web3 for Developers, where we dive into solutions in the blockchain space. Today we're going to talk about the MetaMask Delegation Toolkit. This video assumes that you know how account abstraction works in the Ethereum ecosystem based on ERC-4337. If you need a refresher, check out the video on ERC-4337 that's been published on this channel, link in the description. What is the MetaMask Delegation Toolkit? It is a delegation framework that allows for fine-grained control of authorization. Delegation meaning giving another party the ability to act on your behalf. Authorization meaning specifying what they can do. Remember, authentication means whether you are who you say you are, and authorization means whether you're allowed to perform a specific action. So why was the MetaMask Delegation Toolkit created? Well, the fact that it's a smart contract wallet framework is not new. It's the delegation aspect that is the key feature. And this delegation can be to humans or even AI agents. What stands out is the granular authorization controls. What you need to understand is that this is really a permissions management framework. In Web 2, you might have heard of permissions management frameworks such as role-based access control or attribute-based access control, which are very common and allow for very fine-grained control. Both of these frameworks help to determine the answer to a very simple question: who gets to do what? However, in Web3, fine-grained control is not yet the norm, which, if you think about it, is weird, because in Web3, actions taken are more often involving assets and high financial value as compared to actions taken in Web2. The MetaMask Delegation Toolkit is presenting itself as a solution to address this. The Delegation Toolkit builds on top of ERC-4337 and involves two main concepts: delegation, referring to who, and caveats, referring to what and under which conditions. Now, what do delegations and caveats enable? To put it simply, any user can allow any other user or smart contract account to control a smart account under specific conditions. Let's go through some examples. First, you can allow address 0xabc to send USDC to 0xdef, meaning only ABC is allowed to send, and when sending, only token USDC is allowed, and only recipient DEF is going to be accepted. No other token, no other recipient, and no other operator or caller. You can even specify the max amount of USDC that can be sent. Second example, we can only allow staking of ETH during a specific block number range. And it doesn't even need to be ETH. It can be the native token of an EVM chain that doesn't use ETH as its native token. Last example, we can allow only for method A to be called on contract X with exact parameter values. So the delegation will not be valid if it's calling a method other than method A on contract X. It will be invalid if another contract is called, and it will be invalid if it's not the exact param values as specified in the delegation. Now, all the conditions above are enabled by caveats, which are written in Solidity. And the neat thing is that all of the above examples and a few more are available out of the box, meaning you don't need to write your own Solidity code, simply specify the params. And by params, I mean if you're using the caveat that restricts ERC20 token amounts in transfers, then simply specify the amount number and ERC20 token address. Now let's see how everything works. First, we have the actual owners of the smart account, and these are the signers. There can be two types. First, an EOA with any number of passkey signers. Second, a multisig. And these are signers for the Delegator, which is the smart contract account in the framework. It's ERC-4337 compliant. It serves as a point of entry for all on-chain actions, and it doesn't need to be immediately created. It can be created in the very same user operation that contains the action that needs to be taken. This is a feature of ERC-4337 that allows for the init code to be specified in the user operation. There is a check for whether it's already deployed, and if it's not, it will be deployed in the same user operation. Now, Through the Delegator, the signers can create delegations. These delegations can be stored off-chain, and they contain important information such as the delegate's address, which can be an EOA or another smart contract account, and the caveats that apply to the delegation. Caveats serve to restrict what delegations can do. Now, for the caveats, their logic is actually contained in caveat enforcers, which are smart contracts that contain the actual logic to implement the caveats. Caveat enforcers can be either pre-built or you can customize one by writing your own. If you're using the pre-built ones, that means you don't even need to deploy your own instances, but just use the instance deployed by MetaMask. Delegates can use delegations, and within the context of the toolkit, this is termed as redeeming delegations. Now let's dive deeper. Let's look at the delegation struct. These are the 6 fields of the delegation struct. As you can see, caveats are specified in delegations. And we have this authority value. For what is called root delegations, the authority will have a constant value. A root delegation is one that has no parent, but may have a child delegation or multiple child delegations. For a child delegation, the authority value will be the Ketchuk256 hash of the parent delegation. This chaining of delegations is referred to as redelegation, which will be elaborated shortly. The earlier how it works diagram was actually simplified, especially when it comes to redeeming delegations. The delegation manager is actually where everything related to delegations happen, from delegation validation to caveats enforcement. It's a smart contract. When a delegate wants to redeem a delegation, it must be via a user operation, which will make a redeem delegation call to the delegator contract, which is practically a pass-through to the redeem delegation call into delegation manager. The delegation manager is a singleton contract, meaning there needs to be only one deployed instance on each chain, though it is possible for there to be multiple instances. In the redeem delegation of delegation manager is a check for whether the delegation is valid. If it's not, then execution will not happen. If it is, then the delegation manager calls the execute from executor method on the delegator contract. The evaluation against the caveats are also done in the redeem delegation of delegation manager. As a side note, everything to do with delegation here is in fact an implementation of ERC 7710. How does chaining delegations work? Say, for example, we have a delegator that delegates to address X, allowing it to spend 100 USDC every month. Now, address X will be able to redelegate to another address, so here address Y1. It can allow it to spend 50 USDC every month. Address X can also redelegate to another address, here Y2, with the same permission, which is to spend 50 USDC every month. This can keep going, so address Y1 can choose to redelegate to another address, address Z, to spend 50 USDC only during a timestamp range. So that is a further restriction. Now, all of these are valid. The scenario where a delegation would be invalid is, for example, if address X redelegates to Y1 and says that it's allowed to spend 150 USDC every month, which violates its parent delegation. That will be invalid. Now, delegator contracts are counterfactual, as mentioned. No contract needs to be deployed until the very first user operation. But delegations can be created anytime before contract deployment too. So how does that work? Well, when a delegator signer creates a delegation, they sign it. It's that signed delegation that needs to be submitted on-chain when redeeming. So between the delegation creation and redeeming, it needs to be stored somewhere. Now, that can be stored anywhere. For development purposes, MetaMask has provided the delegation storage client, but this is not available in production. So if you want to deploy to production, you will need to implement your own storage client. Now, when a delegate wants to redeem a delegation, it needs to retrieve the delegation first from wherever you have stored the delegation, the signed delegation. It then submits that signed delegation in a redeem delegation call via a user operation. So how can you build with the MetaMask Delegation Toolkit? The best place to refer to is of course the official documentation. First, install the Delegation Toolkit package. In your client-side code, you need to set up a VM public client. You then need to set up a bundler client because you need to submit user operations. And then you can create your Delegator account. And here you can choose to create a Delegate account using the toolkit as well. But the Delegate account can also be an EOA, as long as later on you submit a user operation. Now, you can create a root delegation, which then needs to be signed. What's missing here is the step to store that signed delegation, which is also missing here before redeeming. So here we prepare the user operation, which is a redeem delegation call. And then we send the user operation to the bundler, which would then validate the user operation. And if everything checks out, then the delegation manager will execute the transaction. That's it. I would like to thank Chintaka and Francesco from the MetaMask team for helping me to gather information for this video. And with that, thank you. Please do like and subscribe for more explainer videos on solutions in the blockchain space. Have a good day.